So, good morning once again, or good afternoon, or good evening. Welcome back. So, in this video, I'm going to talk about the 7 QC tools. Okay? So, this is related to the visualization of data. At ito talaga ang task nyo. Okay? So, these QC tools were the first tools developed to improve the process. And these tools are used in Lean and Six Sigma, in any quality improvement initiatives. Okay? So, like for example, Lean Six Sigma. So, ang framework ng Lean Six Sigma ay DMAIC, di ba? Define, measure, analyze, improve, then you control. So, for each phase of the Six Sigma process, there are tools you can use. Okay? Ayan. Ito, stratification. The act of sorting data, people, and objects into distinct groups or layers. Ayan. So, here, in this, you have different sources, reactor 1, reactor 2, reactor 3. So, makikita natin na ang reactor 1 and 2, mas mataas ang output for the same amount of input kaysa reactor 3. Diba? So, for the same input, the X value, tignan mo yung output ng reactor 2 and reactor 1. Okay? Mas mababa. Mas mataas kumpara sa reactor 3. Okay? So, katulad ngayon, in this pandemic, if you sort the data of the mga cases, you can sort the cases of yung positive cases ng may COVID-19 by what? By age. At nalalaman natin na mas ang vulnerable talaga yung mga nasa may edad. Okay? Kaya bawal ang mga seniors na umalis. So, you can sort also the data by gender, by sex, male at female. So that's the beauty of sorting data, classifying data into distinct groups. You can detect patterns. So we can also see that higher inputs give lower outputs. Tingnan natin. So the higher the input, the lower the output. Diba? Tingnan mo. Ang taas ng input, and yet kumpara mo ito sa ito for the same reactor. So 0.1 input, 99, above 99 ang output. Yet 0.5 input, only about 98.2 ang output. Okay? So the same is true for reactor 2 and 3. So the higher the input, the lower the output. So from here, makikita natin na para rin itong scatter diagram matatawag. Okay? So check sheet. So here's an example. Make a check sheet and then a Pareto diagram for the following car repair shop data. So kung itatali natin ito, makikita natin na ang pinaka most availed service for a car repair shop ay yung lube and oil tsaka brakes. Okay? So anong saysay nito? Anong silbi nito? Anong gamit nito? So kung ikaw car repair shop owner, you can use this to hire workers. What kind of workers do you hire? Okay? How many? So that is, you can use the data in your planning function and organizing your workforce. So dapat pala mas marami akong tao i-dedicate dito sa lube and oil at saka sa brakes, di ba? So ang skills that they need, that you require, dapat marunong sila nito kasi ito yung madalas na ginagawa. Yeah. So for the same data, so you can also do a Pareto diagram. So this is Pareto is from an Italian economist. Nakita niya na that 80% of the nation's wealth is controlled by 20% of its population. Yan. So the 80-20 rule. So application nito sa business ay 20% of your 80% of your problem or symptoms are caused by 20% of your operations. Yun. Okay? So that's Pareto diagram. Again, you can create a Pareto diagram using Excel. Ganun so histogram, na-cover na natin to. So that's the beauty of of summarizing data. You'll be able to detect a pattern. Kasi kaya nagagamit sila itong Pareto diagram, yung check sheet, even yung histogram, nagagamit sila sa problem identification. Okay, if you recall. Yan. Definition, even measure problem identification and measuring how big is the problem. Okay? Yan. So, cause and effect diagram, also called the Ishikawa diagram or the fishbone diagram. So, you can build this in identifying the causes. So, ang nakikita natin, sinasabi nating problema, actually effect lang yon. So, through the Ishikawa diagram, by clustering your resources, ito yung mga resources natin: measurement, materials, method, environment, manpower, machine. Okay? You'll be able to identify the causes. Ito yung causes, kaya nangyari ito. Okay? Kaya nagkaroon ka ng problema. So, cause, then effect. Kaya cause and effect diagram. Then scatter diagram, I think we've covered that also in the previous video. But here's another example. Okay. Then control chart. So komplikado na ito. Okay? So there will always be variations, no? Ang tanong ngayon kasi, kahit anong, lalo na kung manually made, di ba? Mas mataas ang variation yun kaysa compared sa machine. But no matter how sophisticated the machine is, there will always be random variations. So ang tanong ngayon is, kailan mo sasabihin na may problema na reject na yung produktong ginagawa ng isang machine? So yun. Kailangan meron kang upper limit, and kaya meron kang control. Meron kang upper limit and lower limit. You determine that. Yan. So ito siguro tinatawag natin tolerance. Hanggang saan this is quite useful, especially kung halimbawa yung sa mga saksakan, di ba? May male and female so may ipinapasok, may the male socket at mayroong receiver na the female outlet. Okay? So dapat swak yun. Ano ang tolerance? Maliit lang dapat ang tolerance ng variation ng mga, kung sick pair yan paano? Pag masyadong malaki yung variation, baka hindi na swak yan, hindi na magkasya. Okay? So that's why you set a limit. That's when you determine, kailangan na siguro i-reset yung machine. Reject na ito. Okay? Yan. So your task is to build a check sheet and a histogram for this number 1. Use na lang for the number of classes when you build a histogram. 2 to the k is equal to yan. And yun na lang the square root of the number of data points to build the histogram. Okay? So yan. So you are to plot a scatter diagram. So madali lang naman to. Excel lang ito. Okay? Tapos ito naman, yan. Pwede rin gawin sa Excel. At ang histogram naman, you can use Excel or you can use an app. Ang daming mga free apps, histogram maker. Okay? You can use online. So, this shouldn't be a problem to accomplish this task. Okay? So, that's it. And thank you.